We've looked at a lot of different properties of partial molar quantities, and so in this video I just want to summarize the main things that we've identified. And so if we have an extensive quantity, whether it's volume, enthalpy, entropy, that extensive quantity for a mixture generally can just be described as the summation of the moles of a particular species in that mixture times its partial molar quantity. Okay? And we could also write it in terms of the molar property of the entire mixture. It's just going to be the sum of the mole fractions times mi bar. Okay? So that's first important question. And then using the relationships of the partial molar quantities, we've also shown that if you're dealing with a system that's at constant temperature and pressure, that this equation also needs to be true. Okay? And this equation is useful because it gives us a constraint for how changes in the chemical potential of the mixture should change. Okay? And so these two sort of equations that I wrote up there, these equations are fundamental rules that thermodynamic mixture models must follow. Okay. So what I mean by that is, let's say if we develop a mathematical model to describe the partial molar volume or partial molar enthalpy of a species, it must follow equation 1 to be what we call thermodynamically consistent. Likewise, if we're looking at the chemical potential of a model, so models for constant T and P must follow equation 2. And essentially, if you develop a model that violates equations 1 or 2, then that model is not right. And you can't believe any results that come out of it. Alright, and so that's the whole reason for why we went through those derivations, is because we want, if we're going to evaluate different models for calculating or predicting our partial molar quantities, we need to make sure that these models follow these rules. The last thing I want to talk about in this video, I kind of talked about these partial molar quantities in the abstract. But, once again, all these equations that we've derived them because we're trying to describe actual physical systems. Okay? So, for these partial molar quantities, we're going to want, to figure out some way to actually, measure what they are. Okay? All right. And so if we're talking about the partial molar volume of a system, like we did in that thought experiment when we were adding water to methanol, you would get those values by just directly measuring volume. To get HI, you get those from what we call calorimetry. So going back to that first video where I talked about if we make this mixture and we measure the heat that comes out of it, that whole type of experiment is calorimetry. So yeah, you would just measure heat changes from your system to get the molar HI. And the chemical potential, this one's a bit trickier to get, or at least conceptually is trickier to measure. But the idea is that you could get your chemical potentials by studying the phase behavior of your mixtures. Okay. All right, and so in the next series of videos, we're going to go into more depth in how you actually measure partial molar quantities.